So in section 2 of chapter 6, what we're going to do is we're going to begin working with parallelograms. Okay, so this whole chapter is about quadrilaterals, anything with 4 sides. So the first section was kind of an outlier section, is working with abstract angles, interior and exterior of any type of polygon. All right, now we're going to really hone in on all the different types of 4-sided shapes, so every type of quadrilateral there is. The first type that we really care about, and the most important, because a lot of other ones are kind of subcategories of this, are parallelograms. Okay, so parallelograms really have 4 characteristics, and I'll point out the 4 characteristics for you. So the first characteristic of a parallelogram, actually the definition of a parallelogram, is that opposite sides are parallel. Okay, both pairs of opposite sides are parallel. So if you look at this diagram on the right, you see that that PS and Q are parallel, and PQ and S are also parallel. So if you have both pairs of opposite sides parallel, you have a parallelogram. Other things you know about parallelograms that are really important are the top 3 parts of this box. Okay, and you can obviously read this box, this little chart on your own, but things that you need to know about this, so you should just have memorized, you can just rattle off at all times, are first of all that any parallelogram has opposite sides also congruent. Okay, so they're going to both be parallel, but they're also both going to be congruent. You also need to know that the opposite angles are congruent. Okay, so the angles that are across from each other. So for example, angle S and angle Q in this picture are congruent to each other. Same with angle P and angle R. Okay, and the last one is that the consecutive angles are supplementary. Okay, so what that means is, if you look here, it says that P and S are supplementary. R and Q are supplementary, and so on and so forth. Basically, angle P plus angle S, or angle Q, that's going to equal 180 degrees. Okay, those are consecutive angles, the ones that are next to each other. All right, and this last piece is kind of self-explanatory, but if you have one right angle, they're all going to be right angles, okay? Because if the opposite ones are congruent and the consecutive ones are supplementary, if one of them is 90 degrees, you know everything's 90 degrees. So I'll show you what these types of problems are going to look like that we need to do with parallelograms. There's one more example for you if you want to see how the textbook people work out these things instead of me. So we're going to find the value of each of these variables. So number 1, all right, they're always going to give you some type of information. Okay, and number 1, all they tell us is that we have one right angle. Okay, these are obviously all parallelograms. Okay, so since you have one right angle, the last thing we just talked about was if you have one right angle, they're all right angles. So you know that this 4y is a right angle and that 3x is a right angle. And we know that right angles are 90 degrees, so we know that 3x equals 90 and 4y equals 90, and it's easy to continue to solve for these. So x equals 30 and y equals, what's that come out to, 45 over 2. Okay, if you wanted to give me 22.5 instead, totally cool with that. Okay, and number 3, I'll work in columns. So number 3 here, right? Another thing that you should just know about parallelograms is that the opposite sides are congruent. So knowing the opposite sides are congruent tells me right away that 6x equals 12. Right, and you see the slashes there anyway, so you see the other equation we'll be able to set up. 6x equals 12. You can divide by 6 and get x equals 2, but we want to solve for y as well. Now, you don't always know that consecutive sides, the sides that touch each other, are congruent. This is actually a specific type of parallelogram called a rhombus that we're going to talk about in a couple sections. But because they all have one slashing on them, you know that all the sides are congruent. So that other equation, 3y equals 12, can be set up from here, and you can get that y equals 4. You can't always know that, but because of that diagram has those slashes, you know you can go ahead and set those equations up. Number 5. Okay. Another thing one of the 5 things that we knew about parallelograms that we highlighted above was that the opposite angles are congruent. So the opposite angles are congruent. So that means that 2y is going to be equal to 5x. Okay, 5x equals 2y. Okay, now that's good, all right, but this problem gets a little bit tougher because we can't actually solve for either of those variables so far. Okay, what I'm going to do is I need to set up another equation. Well, the other equation is going to be set up based off of this angle. You know this big angle over here. All right, that big angle is 55 plus 60. okay, because you could add up to 55 and the 60, and you're going to get 115. So you know that big one is 115. Okay, so because of that, you can set up some other equations. You can actually figure out what the 5x and the 2y equals, okay? Because you know that consecutive angles are supplementary. So if this one's 115, you could figure out what these two both are, because both of those have to add up to 180 along with your 115. So if you do 180 minus 115 in the calculator, you're going to find out that these are both 65 degrees, right? And remember, the reasoning behind that is the fact that consecutive angles, the angles next to each other in a parallelogram, are supplementary. Okay, so those are both 65. So now I have better equations. I've got 5x equals 65, and I get that 2y equals 65. So I can solve both of those. X equals 13. Y equals 65 over 2. If you wanted to give me 32.5 for y, that is fine as well. Okay, over on number 2. Number 2, a couple things going on here. First of all, we always know that opposite sides are congruent. They're parallel to each other, but they're also going to be congruent. So because they are congruent, we know that 8y equals 88. Oops, that's the worst 8 I've ever drawn in my whole life. Okay, divide both sides by 8, and y equals 11. Okay, the other piece of information here that we know is that opposite angles are congruent. These two have to be the same. That square means obviously 90 degrees, so I know that 6x equals 90, and x equals 15. All right, number 4. For number 4, we're sticking with the angles, okay? But I'm not going to go straight for setting those two equal to each other. All right, the reason for this is because one has an x and one has a y. So I wouldn't suggest that. What I would do instead is I would try to see if there's any way that I can combine these two angles, because they both have x's in them. And I know that's going to give me an equation I can solve. I actually can combine those because we know that they're consecutive angles right next to each other. And consecutive angles are always going to be supplementary. Okay? So since these are supplementary, you can add them up. 6x plus 12x. Set it equal to 180. 18x equals 180. So x equals 10. All right, now that information is going to help me up to find y. Okay, because I know, if I plug that back in, I know that this little angle down here is 120, right? I plug that 10 in for x, and 12 times 10 is 120, right? And 120 is going to be equal to my 3y, because they're opposite angles, and opposite angles are always congruent. So 3y equals 120, divided by 3, y equals 40. Last problem on this page. Right, this is just a very straightforward one. Right, you just got to set the opposite sides equal to each other because opposite sides are congruent. All right, but I'm going to be very specific about which one I choose first. Hopefully you'll figure this out, but I'm not going to use the 2y and the 72x first because it's two separate variables. Instead, I'm going to combine the 150 and the 30x because there's only one variable involved. I can actually solve for it. So 130x equals 150, or sorry, 30x equals 150, so divide by 30, and x equals, that's not an equal sign, that's a 5. Yeah, that's an equal sign. Okay, x equals 5. All right, now that I know that x equals 5, I can plug that in to my 72x, and 72 times 5 comes out to 360. Okay, so that will create my second equation for myself. 2y equals 360. Okay, divide by 2, y equals 180. Now, one last thing that you know about these is something about the diagonals. Okay, the diagonals bisect each other. Remember, bisect means they intersect at the midpoint of each other. So they're going to cut each other in half. They're going to cut them into two congruent parts. So I'm going to make the little slashes up here to show us what that looks like. All right, since P is the midpoint of both DB and AC, I know that AP is congruent to PC, and PB is congruent to DP. Okay, that second part, creating into congruent triangles, all right, that's easy to prove, but we're not writing proofs here, so we don't need to worry about that too much. Okay, what I need to do is just solve a couple equations here. Okay, so if I want to find each variable, all right, that 3x is going to be equal to 12, and then the 4y is equal to 8. So I've got 3x equals 12, so x equals 4. and 4y equals 8, so y equals 2. Okay, pretty straightforward. The diagonals bisect each other, so they cut each other in half. And number 4. Okay, diagonals bisect each other. Don't forget it. So I can get that that we've got 10 equals 3x. Okay, you know those have to be equal to each other. Divide by 3, and x equals 10 over 3. Now, in order to solve for y, okay, we're going to actually have to use some information that we haven't covered yet. So we don't need to worry about solving for y in this situation, okay? And number two, we've got that these two are congruent. Okay, so the 2y and the blank spot, right, are both congruent. We also know that the 2y is congruent to the 28, and the blank part is congruent to the 4x. So we know they're all all have to be the same in this case. All right, so because of that, I can set up the two equations that 2y equals 28, because we know every single one of them has to equal 28. So y equals 14, and 4x equals 28, so x equals 7. And number 5. Okay. And number 5 here, right, the only one that we're going to, again, need to solve for is just the 3x. Okay, I'm not going to worry about the 12 and the 2y. It's once again using some information that we haven't covered quite yet with trig. So what you need to know here is just focus in on this little guy right there. Okay. So if you look at that triangle, right, you know you already have a 90-degree angle here, and then these two angles are congruent. Since those two angles are congruent, you know that they both have to be 45 because it all has to add up to 180. Okay, so because of that, it creates our equation 3x equals 45 divided by 3, and x equals 15. Okay, the last two on here. Right, in number 3, we know that these lines are parallel. Okay, so we haven't used that quite yet, but because we can use that, all right, it's going to help us find our angles for 2x and 4y. So actually what's happening here is this transversal that cuts the parallel lines in half, or cuts the parallel lines, right, it's going to create some alternate anterior angles at 2x and 4y and set those equal to each other. So we know we solve for one, we'll be able to solve for the other. Well, also, since this has all 4 of the sides congruent by those little slashies, you know that these diagonals cut each other at a right angle. Okay, so since they cut each other at a right angle, we know that 2x has to be 30 degrees, because if it's a right triangle, and it's got 60 as one of the degrees, you know the last one has to be 30. So 2x equals 30, and x equals 15, and 4y equals 30, or y equals 15 over 2, or 7.5. Okay, number 6, you have to use the Pythagorean theorem with these right triangles, so you can more than welcome to do that, but I wouldn't ask you to do something like that because we haven't gone over it specifically quite yet. Okay, lastly, coordinate geometry. What you need to be able to do here is work through something like this. So if we graph this, we're just going to do number 8. We go -4, 3, all right, 2, 3, -1, -2, and -7, -2. All right, and you connect these dots, you need to be able to prove that these are, we're going to find the diagonals of these. Okay, so in order to find the diagonals of these, I'm going to obviously draw this, and I'm going to look at it. All right, and I can pretty much see that it's -3, 0. If you can't do that, all you got to do is find the midpoint of one of these. So here's A, and here's C. Okay, if I find the midpoint of those two, all right, remember it's the average of both. All right, so -4 minus 1 is -5 over 2, so it's actually not exactly -3, and then 3 minus 2 is 1, and 1 over 2 is 1/2. Okay, so my drawing isn't exactly to scale, so that's actually the intersection of the midpoint. -5 halves 1/2. Okay, so make sure you go through the midpoint formula like I just did.